So in this video, we are going to see our example 2 on integrating factor, and we are going to solve one of the last example on this topic of integrating factor as a way of solving exact differential equations. So now let's go on direct. We go and find the values of m and k such that x raised to m, y raised to k is an integrating factor to differential equation given below. So that, of course, integrating factor must satisfy the exactness of that equation over there. So now let's go to the solution. So first thing first, we go and multiply. We're gonna multiply this integrating factor with this differential equation over here, so that we can obtain the exact differential equation. So we multiply, we get x squared. Because of the addition of m plus 2, we obtain 2 plus m, and y is raised to k plus m, that is this one plus k. So this one is the equation which we obtain after multiplying with the integrating factor, and also we multiply with this one across the equation. So now we continue to multiply this part of m, and we obtain this resulting solution. To test for exactness now, to test whether now this equation is exact. And we know that this, of course, by multiplying with the integrating factor, we obtained exact. So we are very sure of the exactness of the obtained equation. So now we differentiate partially with respect to ym, and then also for n with respect to x partially. And we obtain the two equations, and we know that the two equations, for the equation to be exact, the integration of m and n with respect to respective y and x, they must be equal. So we equal the two, and now the corresponding values over here, k plus 1, 6, and this other value over here must be equal. So this one and this one must be equal for these two to be equal, and also this one and this one must be equal. Or rather, you can use another method. You can equal the values of x's. 2 plus m must be equal, the same. Also this k and k, they are equal. So there are a lot of things actually you can use to solve these unknown values. Also, you can use this part. You can also use this part. You can also use that part. You can use the value of x's, m and x. You can use it 2 plus k plus that one. You can use the same, and you will obtain the same values of k and m, the unknown values. So let's go on and use these parts. K plus 1 and 6. We equal the 2 over here, so we can see 6, k plus 1, 3. So we have just equal to this one, and then also we equal for this 4 plus 3k over here. And you can continue and solve using simultaneous way. You can use substitution, you can use elimination method, but here I've decided to use substitution method. So I substitute for m, and then I replace on our second equation. So over here I have replaced it, and I obtain the value of m to be 2k minus 1, and then now I go on and replace over here with the value of m on this side. So with that I can obtain the value of m over here, and then I replace it. I go on now and solve for k. I get 2 over here. Now after getting that one, I know the value of m is given by this equation, 2k minus 1. So I just input the value of k into it, and I get 2 into 2 minus 1. So I get the value of m now to be 3. So the value of m is 3 and the value of k is 2. And that is it for this video. Have a nice time.